Smart devices and the Internet of Things are increasingly becoming more integrated into people's spaces and environments. However, to control these devices, existing solutions constrain the user to their mobile phone scrolling through lists and opening separate apps. Although smart speaker systems attempt to unify this ecosystem through voice commands, these interactions have limited expressivity, especially when dealing with a large number of spatially distributed devices. We propose Minuet, a multimodal approach that combines localization, freehand gestures, and voice input for richer and more expressive IoT device interactions. First, we can localize objects within a space using an ultra-wideband sensor scheme, providing localization accuracy of up to 33 centimeters. Using the same hardware, users can wear the sensor on a watch form factor, allowing the system to localize the user within a predefined space, such as a home. Moreover, users can also tag different IoT devices to register their spatial locations, allowing the user to easily set up a three-dimensional IoT space. As UWB becomes increasingly low-cost and accurate, we can expect one day it will be integrated into IoT devices as well as our living environment. In addition to UWB model, the watch also contains an IMU sensor that provides pointing orientation. Together, we can infer which object a user is pointing at within a physical space. Finally, we can augment this interaction with voice input, allowing the user to specify commands and parameters using natural language. This unique combination creates a rich set of interaction capabilities that are otherwise cumbersome or impossible to perform on existing IoT platforms. We implemented several example applications, some of which intentionally expands and stretches Minuet's core idea to demonstrate its applicability to other familiar HCI scenarios. First of all, Minuet allows user to control appliances by their choice of modality in terms of different contextual situations.
Turn this light on.
In this scenario, the user used a verbal command to turn on a light, and choose to perform a silent swipe down gesture to turn it off at night time. Also, Minuet endows the user's verbal command with contextual information.
Turn off the lights here. Turn on the lights here.
Minuet allows the user to select multiple appliances to execute the same command.
Turn on this, this, and this lights.
When a pointing selection is ambiguous, Minuet allows for verbal or gestural disambiguation.
Turn off the light.
Naming devices and zone registration are also being supported in the system.
Turn off silver. Name it as silver. Turn off silver. Turn off silver. Turn on the living room lights. Register the living room. Set. Turn on the living room lights.
Furthermore, user can provide indicating information for the appliance.
Clean this off.
Also, the user can adjust the appliance's status by continuous gestures plus voice commands.
Model.
Every time I go to sleep, I might as well be blind.
Set.
You I see, just like you're haunting me, like a ghost in the darkness.
Show my slides.
In this scenario, the presenter authorized the projector to access his personal slides, which can be controlled by gestures. As an audience member raises his hand to ask a question, the presenter points at him as an acknowledgement for authorizing him to control the slides. Last but not the least, Minuet can not only make smart appliance smarter, but also turn the dumb object to smart. In this bank scenario, the bank clerk's monitor is able to conceal sensitive information according to who it is facing by attaching a Minuet module on it. Besides those, user can interact with the predefined physical object which doesn't have any circuit on it.
Waking up at 7.
In this scenario, the user pointed and commanded the nightstand, which is predefined as a multimodal alarm, to wake him up.
Now in the morning I sleep alone, sweep the streets I used to know.
And later, he used a silent down swipe gesture to stop the alarm.